today is February the 11th, and I'm just going to start recording with Math Workshop. At the beginning of class, the kids come in, and they are supposed to work on Math Workshop. Today, kind of passed back papers, and we've had some talks about schedules and stuff. But basically what happens from here is they have a few minutes. Today, they're only supposed to do 1 and 2, and then we kind of talk about it. Kids should have the exact answer, but some of us aren't exactly listening totally, so here we go. I hope we're all going to jump in there today. Here we go. Okay, so looking at number 1 here, it says Greg bought 5 large popcorn that each cost $12. So what you think about that? Like, if you go to the movies and you buy 5 large popcorns and they're all $12, is it 5 plus 12? No. 5 times 12. Okay, so it's 5 times 12. Okay. And he buys X small. That means we don't know how many small. We got a variable. Okay? And they say that the smalls are $8 each. So we don't know how many he bought, but we know that they are $8 each. He calculated the total cost. Now, I want you to think about it. When you go to check out, how do they find the total cost? Add them up. Yeah, they add them up. Add up all those popcorns to get the total cost, which is C. Okay, so that means in the end, the total cost is C. Okay. Now, well, wait a minute, I might have lost that part. Okay, so he says that the total cost is C as the sum of 12 and the product of X and 8. Now, give me a second. So, let me do it this way. Here is what he bought. Period. Do we see the period? Okay. This represents what he bought right there. That math problem represents those numbers and those patterns. This represents large popcorn. This represents small popcorn. We know we got to add them together before we can ever check out and get our cost. Okay. But the second sentence is where it gets a little confusing. This is what he did. When he got up there, this is what he did. He calculated the total cost, C, as the sum of 12 and the product of X and 8. 8 times X. Product meaning multiply, right? So this is what he thinks it should be. But this is what it should be. What is wrong?
He did 12
Yeah. How many large popcorns is he thinking he's buying here? 1. But he wanted 5. So his math is off. Even though we don't I don't walk up to someone and go, oh, I forgot to multiply times 5. But I know something's wrong, okay? So look, taking what he did and taking what was supposed to be done. Look at letter A. Did Greg correctly equate the total cost of the sum of 12? Nope, we know that one's not it. Because that's not correct. Okay, number B, or letter B. Greg is incorrect. He should not include the cost of the large popcorns. The total cost C is the product of X and 8. So can he just forget about the large popcorns? No, that's stealing. You can't do that. Okay, letter C. Greg is incorrect. He interchanged the constant and coefficient. Exactly. So I even did this. I went, okay, what if I read the next sentence? Let's just see if we can figure this out. It says the total cost, C, can be found by adding 8 to the product of X and 12. So did we put together X and 12?
No.
No, we put X and 8, but we didn't put X and 12. So even not knowing the definitions of constants and coefficients, guess what?
So wrong.
It's still wrong. So like, sometimes don't shut down. They're just putting that to scare you, I hate to say. Or that's what I think they're doing, but anyway. Okay, letter D. Greg is incorrect. He included the cost of only one large popcorn. The total cost, C, can be found by adding 60 to the product of X and 8.
Yes. Yep.
Why 60 though? Why does 60 work?
Because maybe it's 60.
Right. This 5 times 12 is 60. And then if you just put the rest of it down there, X8 or 8X, that is all it is. So yes, like that works because that's the same as that. Yes.
So it doesn't matter what side we put the variable on?
Nope. I mean, officially it should be 8X, but if you don't, because I think in the sentence they're saying X plus 12 and things like that, it doesn't matter officially. Not really. Okay? So you're kind of picking it apart, but putting it back together. Okay, the next one, number 2. The height H of a triangle is greater than 12 centimeters. So the height is greater than 12 centimeters. Which inequality represents this scenario? D, yes. H is greater than 12. We can't use this one because it says equal to also, right? So we can only use the one that says greater than. Height greater than 12. Okay, yeah, and that one's the wrong way. It's H is less than. Okay, good. Now, will you take that and click it behind Math Workshop? Because if you're here today, I shouldn't have to give you another copy tomorrow. Thank you, thank you, thank you. Click it in your binder right now. Click it in your binder. Click, click. Let me hear a bunch. Be ready to show parents those grades. I'm going to probably send out a remind that, hey, your kid got some papers back today. Okay? Now, today, we are still talking about ratios, equivalent ratios. We are now going to fill in what is called a ratio table. All it is what I call cute little boxes with a bunch of numbers in it, okay? And for some of you guys who are out, what we did is we talked about we can compare things using numbers. So, I might say there's 10 boys to 12 girls. I might say that there are 4 kids wearing sandals to 25 kids wearing tennis shoes. Then what we did is we would simplify. Stop, please. Stop, please. No, back up. Thank you. Perfect. Basically from there, we talked about that, like, if the ratio is like 10 to 20, 10 boys to 20 girls, then we are going to simplify it, okay? Now, we then also talked about something called rate, which was taking, let's say I say something like, I have 10 apples for $10. How much is one apple? $1. So we took it from a $10 for 10 apples to $1 for one apple, okay? We took it from a rate, which I call big number, down to a unit rate of 1, okay? How much is 1? So basically, this week, we're going to use kind of like calculating the ratios to help us solve what fills in the blanks on these. What we will use the ratios either simplifying or making them larger to solve these ratio tables. Okay. Now, start now. A ratio table all it is, I just call it this. It's a cute box. It's got a bunch of numbers in it, but they mean something, okay? It is a table with columns that are filled with equivalent ratios. And I want you to think about this. It's kind of like if I say this. If I say I ate 2/4 of a pizza, and then I look at you and I say I ate 1/2 of a pizza, it's the same thing, right? It is. 2/4 is just cut different. When doing equivalent ratios, these have got to be equal going across. Now, I'm going to kind of show you the goofy example that they have on here, but it's a little different nowadays. Back in the day, and they still sell it, but back in the day, they would sell this, which they still do, but it's this canned frozen drink, okay? It would be in like this papery metal can, and it was called concentrate. They called it concentrate. All it is it would be the juice, the liquid or whatever, to make the juice. So, parents would go get this can, and it might be to make orange juice. So, when you got home, it was frozen. When you got home, you took the metal lid off, and you would pour it in the pitcher, and then on the directions on the can, it would say, fill this up 2 times or something, or 3 times full of water. And you'd fill the can up 2 or 3 times, pour it in the pitcher, and stir it up, and voila, you have juice. Okay. Well, I guess this question was just written a long time ago. I used to buy that kind of juice, but then I realized I didn't have enough room in my freezer because I would need like 10 of those things. The world has gotten into what's easier. Okay, so I'm showing the children this, which probably, okay, Crystal Light packs and a water bottle. Okay, now, here's the thing. We've all gone to this, which is powder packs, okay? This is concentrate. This was water before I filled it with this stuff because I needed it at lunch, okay? So imagine this being a bottle of water. If you pour this concentrate in this water, it turns out to be my Crystal Light, okay? There is a certain ratio that should be mixed. If you buy like the little single serving packs, it's supposed to be in 1 water bottle, okay? And voila, you have this perfect drink to drink, right? Well, my problem was I kept buying water bottles that were too big, and I would have the little single serving ones, and when I poured it in there, I was like, this didn't taste good. Yeah, so I would buy the bigger ones, and these are supposed to be for a pitcher, a 2-quart pitcher. So you're making a big pitcher of it. Does that make sense? Okay, so this is concentrate. So once you think about it, if I bring this down a drop. Okay, so if I have 1 of these for concentrate and 3 water bottles, what if I have 2 of these now? How many water bottles do I need? 6. Because it's got to go up evenly or it's not going to taste right. Okay? So if I had 3 of these, let's say I have a big jug I'm making Kool-Aid for. If I have 3 of them, I need 9 things of water. Here's the deal with this. Without it being mixed correctly, it's not going to taste right. Does that kind of make sense? A little bit? Here's the key to this. And I need your brain to kind of keep this in its mind while we do this. Multiply, divide. Don't do add or subtract. Multiply, divide. Okay? I realize, and I'm trying to show you a hint so you don't miss them all. I realize that this just goes 1, 2, 3, 4, and 3, 6, 9, 12. But it's really doing it because of multiplying. So I want you to look real quick. Look at it as I write. How can I get from a 1 to a 2 with multiply or divide? Sorry. Times what? 2. Okay. Well, is 3 times 2 6? Yeah. Times 2. What you do on top, you better do on bottom. Okay. Can I get from a 1 to a 3?
Yes.
By what?
3.
Times 3. So 3 times 3 is 9. So if you do like times 3 on the bottom, you got to do times 3 on top. You might be doing division. You might be making the numbers smaller. Okay? So this whole thing is based on multiply divide. Are we ready?
Yes.
Here we go. It's not hard, I promise. Okay, we're going to use this ratio table to solve each problem. Okay? And it says, how much total does he receive after 4 weeks? Now, I need you to know something. Hint, hint. This is the only box that I have to check. The other boxes you may use or may not use. That's the weird part, okay? This is what I do. Please listen, because like some of you are looking at the floor. Okay, so look. I find the two that are across from each other, like that 1 and that 4, both stand for numbers of weeks. Can I multiply or divide and get from a 1 to a 4 with a good whole number?
Yes.
What is it?
4.
And is it multiply or divide?
Multiply.
Multiply. So if I do 1 times 4, I get 4. Well, look at the top. If his allowance is $7 for 1 week, 7, I got to do times 4 on top, would give me, what's the answer? 28. 7 times 4 is $28. So if in 1 week he gets $7, we know in 4 weeks he gets 28. And it's all because of the times 4 thing. Okay? Now, the weird part is this. Someone else might have to say, well, I know in 2 weeks he would get 14. I know in 3 weeks he would get 21. And 4 and so on. That is fine. You could have 10 boxes between here. As long as that one's a 28, your answer's right. Okay? Good so far? It's kind of weird because some of them are so easy and then some are like, huh? Okay? Let's look at the next one. Tanya runs 8 kilometers in 60 minutes. At this rate, how long would it take her to run 2 kilometers? Okay, so look. Take the 2 that are across from each other, which is 8 and 2. Can I get from an 8 to a 2 using multiply or divide? Divide what?
4.
4. 8 divided by 4 is 2. Everybody agree?
Yes.
Okay. Can I do 60 divided by 4?
Yes.
And what do you get?
15.
15. Okay. Well, you've got a couple choices. You're either going to have to think, can I get from an 8 to a 2 using division or multiplication?
Yes.
If you can't, we'll see one in a second where you may have to do some other work. Okay? But so far, these have kind of worked. Good so far?
Yes.
Okay, y'all are scaring me. Okay, look at the next one. This is my example that is definitely,
Wait, you don't have to say like in the middle?
that's what I'm saying. You don't have to. If you can get here without the middle, you're fine.
Oh, so.
But,
Wait, will we have to
yes, this is on Friday.
fill out the middle?
No, listen. So let's say you have this same box. Okay, same exact numbers. Does everybody agree? Okay, I'm going to cover this one up. Pretend like you never saw it. Okay, what if I said, you know what? I don't know how to get from an 8 to a 2 using skills of regular fast facts. So, I know that this thing simplifies. So what if I simplified it by 2?
30.
That would be 30. What would the top be? So if I divided by 2,
4.
that would be 30. And the top would be 4. Okay. Can I get now from a 4 to a 2?
Yes.
4 divided by what? 2 is 2. 30 divided by 2 is 15. Notice, you get the same answer. All it is one kid didn't need the middle box. One kid needed it. It doesn't matter as long as we all get that 15 right there. Okay, I have had ones before where I had to add boxes. And it was just crazy. Like I went out way too far before I came back to where I should be. It's weird. Okay, so look at the next one. Ounces of soft drink, teaspoons of sugar. Okay, can I jump straight from a 12 to an 18? No, nothing. 12 times nothing's 18. 12 divided by nothing's 18. I gotta use the middle box, okay? Now, noticing a 12 and a 10. What can we do with those numbers? Divide them by 2. Okay, so I'm going to just trying. I'm going to divide by 2. 12 divided by 2 is 6. 10 divided by 2 is 5. Okay. And listen, it's almost like a guessing game. Because can 6 go to 18? 6 times what? Times 3 is 18. Well, can I do 5 times 3? And I get 15. It's just weird. Like the pattern I use may be different than yours. Okay. Now the last one is making a ratio table. Okay. You start out by labeling the table itself. Okay. We're going to put packs of juice. It says Lamika buys 12 packs of juice boxes that are on sale and pays a total cost of $48. Okay. So, we're going to we need words, just like the ones up here. Packs of juice boxes on top. And on the bottom, it is total cost. Yes, your pencil should be writing this with mine. Listen, try to watch the review video, and it will probably help you get through the test chunks. Okay? Come in the morning, I'll be here. Okay? In the morning, I'll be here if y'all need help and or those registration sheets initialed or signed or whatever. Okay? So first, write down packs of juice boxes and total cost. Okay, we got to know what our numbers stand for. That's the whole thing about a table. Okay, so how many packs of juice boxes? 12, and their cost was $48. Okay, and I'm just pulling, y'all see the numbers. I'm pulling them right here. 12 packs to $48. See where I got the numbers, right? I'm not making them up out of the sky. Okay, making sure. Now, here's the last part. It says, how much would Lamika will pay to buy 8 more packs? Be careful. 8 more packs. So she's already got 12. If she bought 8 more, how many is she trying to buy?
Wait, so you have to add 8 to 12 and 48?
No, slow down. She wants 8 more packs than 12.
Oh.
She has 12. She wants 8 more. What's her total number going to be? 20. Okay, so they're wanting to know how much is 20 packs of juice. Okay, right here it says, what if she wanted to go buy 8 more packs? So, because it's on the top, the packs, the only reason I added 8 is because they said more packs. Okay? I wish they hadn't started with this. It's kind of a harder one, but I get it. Now, right. I mean, they could have said anything. They could have said, what if, she only has 2 packs or something. So think about it this way. Can we go from 12 to 20 easily?
Yes.
Not super easy, though, right?
Well, times 2. What? No.
No, because 12 times 2 is 24. What can I do to get, what numbers you think I'm working with?
12 divided by 2.
Okay, so if I did divided by 2, I would have, if I did divided by 2, I would have a 6. And if I did divided by 2, I would have a 24. Okay. Can I get from 6 to 20 now?
Yes. No.
6 times something's 20?
No. Divided by 2.
Okay, let's divide by 2 again. If I divide by 2, I get 3. And if I divide by 2, I get 12.
And then now you
Can I get from a 3 to a 20?
Oh my God. I don't have this is hard. How do you split that?
Okay, but 3/12 simplifies by what?
4. 2.
It turns into, the 12 turns into a 4, but what are we simplifying by? 3. What if I divide by 3 right here? 3 divided by 3 is 12 divided by 3 is, can I get from 1 to 20? Times 20. What's 4 times 20?
5.
4 times 20.
I'm at
80. Listen, don't be packing out. Listen for just a second. Way back here, 12/48. You could have done what? Did anyone see a faster method? What was it?
6.
Divide by 6. And you would have gotten 2 and 8. And then multiply times 10 to get 20 and 80. It doesn't matter as long as we all end up with 80 on the bottom. Okay? Now, the homework tonight is this ratio worksheet. And it's pretty easy. Please don't need one more. Wait. If you are leaving, grab it.
Get your stuff for it.
I know.
Okay. Don't forget to hit that subscribe button and the bell icon. Okay.
Good evening. Did you get one? Did you get one, Yana? Okay. Look at one of those captions. I have no clue. Did you get one? Okay. So, tonight's homework, I need you to listen, is this worksheet. Now, okay, it is ratio table homework, and the problems, we need to get these answers. It is, honestly, this is the important box. The ones in between, you may not have. Okay. Going down, there's 6 and 7, 8 and 9, 10. Okay. On this last one, you need to make a ratio table. Make a ratio table. Okay. So, looking at like number 1. Here we go. It says to make 5 apple pies, you need 2 pounds of apples. How many pounds of apples do you need to make 20 apple pies? So can you get from a 5 to a 20?
Yes.
By what?
4.
Times 4, right? Okay, so if times 4 up here, 2 times 4 is 8. So I would need 8 pounds of apples to make 20 apple pies. Okay, finish this for homework and we will go over it tomorrow. It's not super hard, it's just gotta kind of think.